Hello friends, today I will talk about how to convert a normal Solar MPPT to a cloud-based MPPT. The idea is actually basically send all information from MPPT to the cloud. Basically the solar voltage, solar current, battery voltage and battery current. The thing is like actually these informations are available on an LCD inside the MPPT, but the thing is like if we want to check this information we have to be in front of this MPPT. So the idea is like if we can send these information to a cloud, basically we can monitor the performance of the MPPT remotely. We will get all the information on a mobile or a PC. So for this actually the first thing we have to do is like how we can extract these information from the MPPT. So initially I thought of decoding the LCD lines. Since we have this information already coming in the LCD, if we were able to decode this LCD line, then we can extract this information. Yeah, but later I understood like it's not so easy to reverse engineering the LCD data lines. So I just think alternate solutions for this. The next idea was like to have a separate sensor. Basically for the voltage readings, we can have a voltage divider resistor network. Also for the current, we can have a current sensor AZS 786, which is basically a Hall effect current sensor. I thought of using these things for getting this information. Then later I thought like why we should go for a separate sensor since we already have this sensor inside the MPPT. So if we are able to trace out these voltage dividers and current sensors, it would be much more easier. Like we can, if we can tap those lines from the actual microcontroller inside the MPPT, we can easily get this information. But the thing is like we should not disturb the actual microcontroller inside the MPPT. I mean the data which is going to the actual controller should be accurate. It should not be altered with the modification which we are trying to do. So I'm able to figure out these lines. So the next idea was like uh, to read this information and find out like how the divider is working. I mean how much is the voltage division happening for the solar as well as battery voltage. Similarly for the current also. So for this actually what I have done was like I have connected a variable power supply to the solar input of the MPPT and adjust the voltages and measure the voltage across the divider network. So with that actually I am able to find out how much factor the actual voltage is reduced and going to the ADC of the microcontroller. So with this information I just start uh, reading this information and try to verify it on a hardware. Basically for this actually I have used NodeMCU for verifying this. The thing is like actually for the NodeMCU there is only one ADC channel, but for us actually we need at least 4 ADC information, basically solar voltage, solar current, battery voltage and battery current. So what I have think of like to make use of a analog multiplexer, so we can have like a select input for selecting different channels, and since we have only one ADC, all these channels can be switched between different channels and we can read all the values, all the 4 ADC values. Yeah, actually I can just show you the schematics. It's actually a very simple schematics. Basically as you can see, the multiplexer input is connected to the A0 pin of the NodeMCU, which is the ADC input pin, and we have the select as well as enable pins connected to D0 to D4. You can see the capacitor very close to the microcontroller. These are the capacitor for the filtering the ADC pins which is going to the microcontroller. So I have taken these data, basically these pins, to the multiplexer input, and from there actually it's connected to the A0 pin of the NodeMCU. Also for the power supply, actually there was a 7805 regulator IC inside the MPPT, so I have taken power from those pins. Yeah, that's the hardware setup basically. Yeah, on the cloud part, actually I have make use of IoT cloud, Arduino IoT cloud. It's actually free. The thing is like we can have up to 4 dashboard. That is the limitation for the free option. There is actually things where the actual data will be updated. The things field we have to configure all the required variables which we will be updating from the uh, client side. So those variables are here, and on the dashboard part, we can have the layout of the dashboard, and we can place all the information which we want to show it on the dashboard. Basically the solar voltage, solar current, battery voltage and battery current. So I have also included a graph which will show the power, since we already have this voltage and current information for, so it's straightforward to get the power value. So I just populate those values also. Yeah, so that's about the dashboard and the IoT cloud. Yeah, actually I'm not explaining much deep in code level, since it will be like it will extend the video timing. So the thing is like actually it's straightforward. It's much more easier thing. Actually there are a lot of example code you will get from the IoT cloud itself. You can start with having a simple data which is populating to a remote cloud, maybe a temperature sensor data or something like that, and you can proceed further on that. The thing which I have added additional to this is like actually I have added OTA, that is actually over the air upgrade feature. Why I have added this one is like, since we have installed the NodeMCU inside MPPT, if we want to program, we need to physically open the MPPT and then we want to flash it. So just to avoid those things, I have included over the air feature, so we can remotely upgrade the software also. Yeah, on the right hand side you are seeing the IoT cloud application which is installed on a mobile device, and on the left hand side it's the actual MPPT charge controller LCD data you are seeing. So yeah, we can see the solar current, solar voltage, battery voltage and battery current informations on both the charge controller and on the dashboard. You may notice that actually the battery voltage is showing a 0.3 volt deviation. Basically on the MPPT it's showing 11.7, but on the dashboard it's 12 volt. The thing is like actually the real battery voltage is 12. I have physically measured the voltage across the battery, it's 12. So on the dashboard it's correct. On the MPPT it was earlier itself, actually there was a small delta of zero point 0.2 to zero point 0.3 volt. It's nothing with the modification I have made, actually it was the when the very start of the uh, MPPT itself. Yeah, that's all. Yeah, thanks for watching my video. Thank you. Have a great day. Bye.